podcast there, Kimon. That was great. I think that's got real good insight. I've got that on my slide. I had to redo my slide. I got so much information in the last over the weekend that changed a whole bunch of stuff. So I had to redo the slide. Yeah, some of this stuff I think it's important that it all fits. It's all kind of fitting together.
Hey, Jim.
Yeah, tell.
Hey, Jim.
Hey, Ken.
So, hello, everyone. We'll wait another minute or two, let other people join us, and then we'll get going. I hope everybody's doing fine today. Spring is finally broken here in North Carolina and everywhere else. How about that for you, Jim? How's it in Boston?
Boston is cold and rainy right now. Although I was in Dallas and Houston last week where it was 92 degrees, so I'm still toggling back and forth.
Somebody posted a post of what have you been in these 20 American cities? And I'd been in 19 of them, and the only one I'd never been in is Boston. This is kind of weird.
Never been to Boston? Wow.
Never been to Boston.
Wow.
Somebody tells me it's quite a bit like Victoria. So
I like it.
yeah, that sounds good. On the coast, it has to be good.
Hey, Keith.
Mm.
Hey, how you doing?
Good.
He's in the car.
Yeah, I'm in transit. I got kicked out of my conference room at Kenny's.
Oh, that's rude.
I dare him.
Yeah.
So I'm gonna cruise back up to the campus. Gonna take all of 4 minutes, but
You need a robocar.
I do.
Yeah.
Yeah, the assistant chief at Cal State has a brand. He's had a Model Y for a long time. Yeah, he's telling me how amazing his FSD is. Like he just sits back, tells it where to go, and it just takes him. He takes trips to Vegas and all kind of stuff.
Yeah, we were
It's just
down to
amazing.
Austin last weekend. It's awesome. It actually took all the stress out of my driving.
Yeah. He said you can tell. I mean, he said, yeah, version 12 a year or two ago was like he likened it to his 16-year-old, like teaching his 16-year-old how to drive. A little bit nervous, But he said, yeah, now it's up to the experienced driver's level. Like he said he feels completely comfortable with it.
All right, I think we should get going here. Let me start sharing my normal thing and organizing my desktop here. Here you go. Okay, so good afternoon. I am Anto Budiarjo, and welcome to Monday Live. This is something that we do every Monday afternoon at 3 p.m. Eastern to try and figure out the future for smarter buildings. So it's really good to have you with us today. In case you're wondering who we are, our profiles are listed on mondaylive.org members page. And just a reminder, the views expressed here in this hour are personal, not of any company or organization. And let's make the Zoom chat the place that we can communicate back and forth here on this hour. Really makes it interactive and great. And if you want anything from this deck, it's also available on mondaylive.org. So this is our fourth Monday in March, talking about governance. So this is one of the long months. So we've got 5 weeks to talk about governance. So we've got one more week. So didn't think the subject of governance would last as long, but it's been a good conversation so far. So let's keep it going. And so our agenda today, normal sort of news and chit chat to get us going. And then we're going to be talking about focused on governance of controls. And Anna's going to lead the charge on that because he knows a lot more about controls than I do. So looking forward to that. But before, as always, I hand it over to Ken Sinclair for update from automated buildings. Ken.
Thanks, Anto. Yeah, lots going on. Governance of controls, that's what we're going to talk about. I was struggling with that at the start. I put it out on Thursday, and I was just talked about the governance of reality. So I think that'll come up in the conversation as well. We have an article written by yours truly there, Anto, is the missing binding layer. And this is a part of a series. There's going to be 3. He's going to have that's the first one. The second one's going to come out on Wednesday, and the third one is going to come out on Saturday. Is that correct, Anto?
Yep.
That's correct. Good. The next one below that is something, a post that Kimon did, and I just plucked out this sheet because I think this is definitely something that is worthwhile taking a click on and look what Kimon's been talking about. The basic concept is basically distributing AI rather than centralizing it, decentralizing intelligence. And he's got a podcast there that is well worth listening to. So I would strongly recommend you take a look at that. He's also published I'm sorry, Dave, I'm afraid I can't open your smart building controls when the system goes rogue. So there's the other side of the page as well. We've also just had a new article just come on the site. Can AI agents run your building? And that's using OpenClaw, which is interesting, and it's a great article. In addition to that, the one below that announces NemoClaw, and I kind of get a kick out of that. Is if you're aware, OpenClaw is like an agent that is able to organize other agents, and it seems to have like superpowers, and they're starting to talk about that. But right away, that last post suggests that they are actually looking at governance because it needs governance. It needs control because it can potentially hurt itself, I think. So NemoClaw, I think, is the idea of not having a complete open claw. It reminds me of when we're looking in the lobster tank or the crab tank, and they've got tapes on their claws to kind of limit them. So some fun stuff going on there. Some real good thought leadership that I think. If we go back over to the left-hand side of the screen, and there's a summary of last Monday's session, which I think we captured pretty well. There was actually this whole governance topic. When we started it for the month, we were kind of soul searching, and we weren't sure that this was the best direction to go. But the governance is a very important piece, and it's exposed a lot of thought that we hadn't really thought. So I think it's been a very good direction that we've gone. The one down below there is we're touching everybody, and here's Netflix. And as you can imagine, Netflix may have a few files they have to keep straight. And what they're trying to do now is they're trying to create an architecture that when they create any kind of data, that's sort of the job is that it has to fit a format, it has to fit a style, and and that'll make their life a whole lot easier. And it's an interesting, again, another podcast that's worthwhile listening to. Below that, we've got one of our sponsors who's just reminding us that how important all of this data is and how it is necessary to, to prove what we are doing. And that actually reappears on the other side of can AI agents run your building? That's called the new standard of seeing. And what the general twist there is that once we get all of this data and we can actually get at it the way we would really like to get at it, then we need to use it as a record of looking at all kinds of things in the buildings, just performance, atmosphere, indoor air quality. And we see it as a moving certification thing that at any time you can basically see the buildings, and it'll also help us sell our technologies because we will actually be able to validate and stuff. So there's some interesting thoughts that are in those series. That's a new editor we have, and he's got very prolific. He's got lots of posts, and they're all got a little different twist, but the story is the same. Is let's have a continuous recording of all of this information that we're kind of envisioning. So that's a great one. Our free education sessions are still online. We're just slowly picking through and doing the summaries. We've got a few more done. I'll give you a link to that maybe next week. And the other one is just reminding us that I think Kimon posted this as well, is the Linus, who invented the Linux way back when. It's what is it? It's 21 years now. He was 21. It's a long time ago anyway. And just what a powerful thing he did, and it was just kind of like a weekend project, and it's sort of changed the world. So that's where that all came from. Okay, so back to you, Anto.
Great, thank you, Ken. You're packing in all of these stories. Eventually, they become so small you won't be able to see what it is on this slide.
Someone suggested you give me a second page, but then it could be dangerous and have twice as much information.
That would be very dangerous.
But actually, the other thing, yeah, the other thing that's happening is the contributing editors are coming alive, and they're not only posting, but they're ganging up and talking to each other and posting each other's ideas and stuff. So there's a whole bureaucracy going on in automated buildings, which I'm really pleased with.
Great to see. Thanks for the update. C4SB update. Rick is late to this call. He said he was going to be late, so we're going to have to skip him. But this is just all of the things going on in C4SB right now. These are the things that are sort of pushing the frontiers to where things are new things going to happen within Netflix, things like UDMI and open building graph kind of thinking and other sort of ways. So that's all great. Ken mentioned this article that I wrote and published on automated buildings, and let me just sort of explain what this is all about. So this is really a story about what has been going on at the PAE Living Building, the PLB in Portland, that Rick and Kimon and other people have been talking about. And really it's a story of starting here on the left here, where the building was new. It was finished a few years ago, so it's a new building, and they have all of these systems in the building that were all working perfectly okay, but they were all in different islands, and they were all very modern equipment with lots of Ethernet ports and all that kind of stuff, but they were not connected with each other. There was no way of anybody sort of aggregating any of the information or looking at any of the information other than going to all of the different tools of the specific vendors, right? So this was not acceptable from PAE's perspective. So they wanted to challenge the industry. And the other aspect of it is that this is a new building, but the material, the assets that, or the sort of artifacts that were handed over to them were just not very useful. I mean, I pictured it here as a stack of paper. It's not as bad as that. It's actually a stack of PDFs, which in many ways is worse because you can't, it's just very, very different concept, but it's still does not allow any of the information to be connected between these all of these different systems. So the team has been working to enable this sort of island systems to be able to be aggregated together, which is really what we want to have in the future. So we can have a completely different view of the building, so we can actually run the building properly, running all of the systems properly as they should be in coordination. So that's really where we're heading towards. So this is kind of a pictorial of the same systems, but all connected with a governance sort of architecture. And so this article is really talking about this is the journey that the group and driven by C4SB as well as the Asset Leadership Network has been working on to go from this reality to this reality. So the link is here, and I'll post it in chat once I hand it over to Anno. But that's really what's going on, and I hope you find it interesting. So with that, any other thoughts before we move on, or questions on any of the things we talked about?
Yeah, Ken, you mentioned your contributing editors. I thought Danielle dropped a very thought-provoking article on automatedbuildings.com. Danielle, she spoke of chaos fueling innovation. I thought that was a pretty good article.
Great, I do agree. The trouble is we're getting all kinds of good articles now. It's just I used to struggle to get content, and now I'm drowning.
And then another thing I wanted to mention real quick is that I think 2 or 3 weeks ago we had the episode where we talked about taking the guardrails off and the safety drivers off of our AI, and something incredible is really emerging from that. Just the short take on it is that our AI has gone from 48% energy efficiency gain to over 60% out here at Cal State Dominguez Hills, where I am now. So took the guardrails off and the safety driver, and the AI is better for it. So stay tuned.
Yeah, I saw your article on LinkedIn, Keith. Well, actually, what's his name? Kenny's article, right? And the numbers he's getting.
It's incredible. Cool. 12% increase.
Cool. And Rick is also with us. Do you want to, do you have any specific update, Rick, on C4SB matters? I just skimmed past the 2 slides.
No, I'm traveling, so I'm sorry.
Okay.
I'll just be mostly just listening in, but I'm sure this is going to be a fun conversation. Chirp up a little bit.
Okay. All right. Let us proceed then. So in the governance, the topic is governance of controls, and this is my last slide. So I'm going to stop my slide and hand it over to Anno. And I think Anno, Ken and I were chatting before we started. One of the ways to sort of maybe think about this conversation is, in a way, governance is a form of controls, right? So where is the line between controls in the domain that we're talking about and the governance of the controls? How can we sort of separate these 2 things that are in many ways very, very similar in concepts?
Yeah, and I think the fact that we've got the word controls and governance in the same phrase, right? And governance implies controls, and controls implies governance in of its own thing, which then should let you discuss whether what is the what is the definition of controls in the context of what we do. So, maybe a quick little history lesson for everybody just to set the stage, because controls, for those who have been involved in it for any length of time, has kind of become a term that we all understand what it means, but outside of our space and industry, it's a little bit fuzzy as to what quote unquote, controls is in the building systems and stuff. But if you go back a few decades, the original control system was, and we'll just use a simple example, right? A VAV box tied to an air handling unit that's tied to a chiller, if you look at that typical sequence. But the initial intent of the VAV box and the controller that sits on the VAV box was to maintain your 72 degrees / 21 degrees FC, set point. That was the whole purpose, right? Keep you comfortable. And back in the day, that was all done by a pneumatic controller. If you remember the pneumatic days, anybody who goes back that far, what we used to call lovingly huff and puff days. And then of course, we changed it to electrical controls, and then we changed it to electronic controls. But it did the same function, right? At the end of the day, measure the temperature, measure the airflow, make sure you got the right amount of cooling going into the space for the particular load. And that was the fundamental purpose of the control system, right? Now, you could also you had controls back at the air handling unit, to make sure that the dampers are modulating for the right airflow. You had controls on the cooling valves to make sure the cooling valve was modulating to the right requirements for the amount of cooling that you needed, and that flowed back to the chiller, and then you had to sequence your chiller. Back in the day, we had simple step sequences, right? For those of you who remember those days, nowhere near the controls that we have today. They were just simple step sequences that would sequence up the chiller, based on load being measured. But that was fundamentally the control system, right? It was all there. It was behind the scenes. As long as it was commissioned, it worked and maintained the 72 degrees in the space, which is what you're after. Then you could extend that model to lighting and some of the other systems that you've got in the building as well, but sticking to the HVAC guys. But because what happened was, once we made it electronic, and once we made that the controller in the VAV box could talk to the controller in the air handling unit, which could talk to the controller in the chiller, still kind of controls, but then we realized all sorts of additional benefits of those controls. And that included, well, since there's a communications bus now and there's a protocol in the network, I could actually see the values. I could see the temperature, and I could see, and again, back in the day before we had that capability, when we had pneumatic or electrical, electronic controls like an electronic thermostat, to see what the temperature was, we'd always put another thermostat next to the controlling thermostat, and we'd put that on a dashboard somewhere, and that would tell us what the temperature is. So we'd duplicate everything. But the control system was the control system. But then when we added the networking and the communications and the protocols, of course, now we could actually see the temperature, we could see the airflow, we could see the set point, we can remotely change the set point, and we can do some additional things to that. And so basically, what we talk about a building management system was the layer that was put on top of the control system. So there was the thing that controlled to 72 degrees, and then we put another layer of technology and software on top of that, which had several functions, one of which was to see what was going on. Just show me what's going on, put it on a dashboard, make the pretty, what I call the, twirly fan graphics to see that the fan's running and all that sort of stuff. It's status dashboard type of stuff. But one was to let me override the controls, right? And to provide some, well, it's 72 degrees, but they're complaining it's too hot, so I'm going to put it in manual and turn the temperature down, right, as a function of the thermostat, instead of sending a guy into the room at the thermostat and tweaking the pneumatics down. So we started overlaying, so just putting aside the informational piece, right, the dashboard and the values and the sensors and stuff. But then we started overlaying a whole lot of controls functionality on top of the controls. And this is really where governance started to kick in. And we did things like, wow, well, we could actually start and stop the air handling unit on a schedule now, right? And we could change the set point remotely, dynamically, based on maybe time of day or occupancy or use of the building. Or I could actually resequence the chiller now based on some other functionality, which was beyond the initial just maintain 72 degrees in the space. And so when you think about it, what the BMS was doing at that time was providing a lot of that governance, right? It was doing the overview of the control system to go, well, I don't really, even though there's a thermostat there and there's a set point adjustment, I don't really want the occupant to adjust it more than plus or minus 2 degrees, right? You could do it in the old pneumatic electric days, the DDC days. It was a bit more of a challenge, but you could do it. But now I could do it all through communications. So I'm actually overlaying a whole lot of governance on top of the control system. And that's what we do today, right? When you think about BMS systems, they predominantly do probably 2 or 3 things. One is tell me what's going on, give me a dashboard I can see, is it the temperature right, is it on, is the fan running, is the chiller running, give me the pressure signals and show me what's going on. Send me alarms and faults and problems, when it doesn't do it. So instead of me having to look at the dashboard all the time, now I can write some additional logic to say, well, when it's not 72 degrees for more than 30 minutes, send an alarm to my pager back then and then to my system, email system or whatever. So I can now make it alert me and tell me what's going on. And then the other one is what I call the controls part, the overlay, the governance of the control system itself, right? Which is to provide a lot more interlocking. All right, let's have a look at all the VAV boxes and all the air handling units in there, and let's see if I can be smarter in something that we used to call, pre-cooling and pre-shut off, right? If I know the temperature going on for the day, and then I could do some pre-cooling so it gets up to temperature by the time that the people come in. Used to set that with a time clock. Now I can do it with some smarts, right? But to me, all of that stuff was what we now call the guardrails of AI. When we talk about guardrails of AI, we have guardrails in the BMS system today, right? We put all those guardrails in place. We made sure that the occupant couldn't do more than plus or minus 2 degrees. We made sure that the thing didn't start too early. We made sure that, the chiller wouldn't run unless all the air handling units were running when the chiller was running. So we put a lot of guardrails. And all those things were all pretty much rules-based type stuff. And this is kind of where I invoke Keith's point. Those guardrails are being run by 20-year-old servers running in the basement of some dusty room that may or may not be running. That someone hasn't looked at for years or bothered to check, and this is kind of where I get a little sideways when people talk about AI, guardrails for AI. I go, do you understand what guardrails you've got your BMS doing today? You probably don't, and you probably don't know. I mean, and it's probably not doing it reliably. So my whole point about that is just to get the conversation going about, we have a lot of governance and control systems. We called it the BMS system. Now, I could extend this one further, right? And BMS systems, which is a large spend for a commercial building owner, right? So they put in the controls bit. There's the cost of the VAV box. There's the cost of the air handling unit controls. There's the cost of the chiller controls and network. That's fine. But on top of that, we put many millions of dollars of BMS systems to provide this extra layer of governance and monitoring and alarming for us to know what's going on. I can see a point in time where I can replace all of that BMS functionality with an edge device that's AI powered, right? Because, and again, the old BMS days, to do all of that interlocking, to do all of that BMS oversight and governance of the control systems, not an inexpensive proposition. I could literally take a GPU, put some AI, and replace pretty much all the functionality of what a BMS system does today. including the reporting, including the alarming, including, and this is kind of where, and I'm going to pick on Keith for a moment, right? What Keith's doing with his chiller AI stuff. At the end of the day, he's really only using the BMS as a convenient way to get to the points. The BMS is not doing any other functionality anymore. The chiller is still doing the fundamental staging. The chiller's still got the fundamental controls where it's physically sequencing the chillers up and down. That's still happening. But all that governance that was provided by the BMS, Keith's not doing that anymore. His machine's doing that now, right?
The robot operator.
I'm sorry?
It's a robot operator.
Robot operator, right? And so I can see that model applying to almost everything. I still think we'll have the fundamental the fundamental controllers that controls the VAV box and the air handling unit and the chiller and all that sort of good stuff. Although, on my back wall, of course, I have a patent for a neural net VAV controller that dates back to the 90s. So you could even argue with the technology today, I could even replace the VAV controller with a neural net or AI driven node. Because again, just thinking about it, VAV, for those of you who ever commissioned a VAV box, it's not trivial, right? A VAV box today consists of a dual cascaded PID loop, one for temperature and one for flow. You got to set up the parameters for all of those. You got to set up the PID values for all of those. Someone has to come in and commission all that stuff. Do you think how many people can actually commission a VAV box today and set up the right PID parameters for flow and temperature? Not a whole lot. What do? They go, these numbers worked before, they're great. I could replace that with an AI edge node these days. The cost has just become ridiculously cheap. So, but I have said on that. So yeah, I mean, the BMS systems that we've been putting in for years at the cost that we've been doing do nothing more than just provide governance over the control systems that we control, that actually provide the functionality. Sure, I can replace all that with a single AI node.
So the control will remain just in their domain, just controlled stuff.
Yes. Controlling a VAV box to temperature and flow.
We were talking about the default mode on Wednesday. How does that come in?
Still does. I mean, it does today. Even in the VAV box today, I have default parameters that I put into the VAV box, right? I make sure its temperature doesn't go up above plus or minus 2 degrees from set point. I make sure the airflow doesn't go crazy, right? Unless it tells me when it does. So all that governance is still local to the control loop that you're controlling, and the default things it should always do that, because we've been doing that for decades. We do that in the VAV boxes and the air handlings. We've always assumed that the network will disappear and something will not turn up. Therefore, how does the VAV control work at that point? How does the air handling unit work when that happens? There you go. There's one. So we've been doing it for years. Nothing has changed, right? We would still do the same. I think the difference is the how that we do it.
So, Jim and Steve, you are very close in your work to manufacturers, vendors of OEM and devices, and obviously, Steve, you are one yourself. Could you relate to what Anna was saying and sort of bring it back to what the industry looks like today in that sort of context?
So I think Anno would agree with me that with regard to the guardrails, in an ideal situation where the specifying engineer has written a spec that describes the guardrails and they actually get implemented, which is reasonably likely to occur at the beginning of a project. My experience has shown that over time, those guardrails effectively disappear in the interest of keeping things running. So, and the individuals who are responsible for running it, what they care about is it running? Yes or no? Is it running in context of the guardrails? I don't care. And so a lot of those guardrails get defeated because they don't really, the people responsible for running them don't even understand fully what those guardrails intended to accomplish. So it's basically over their heads in many cases, not all, but in many cases. And I say, see Keith, I see you're shaking your head a little bit in agreement with me, right?
Yes.
So there's this kind of corruption over time with regard to the guardrails.
Perfect word.
So 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 how do you recover it? And not easily, because of the turnover and did do I bring in a different systems integrator, and will that systems integrator necessarily understand the original guardrails and be able to re-implement it or not? It's a crapshoot. So to the degree to which AI can come in and become that knowledge resource that doesn't age out, doesn't get sick, right? Um, and can be trained to get smarter as well over time, right? Wow. All of a sudden, I've got what feels like you know, what was the word I'm looking for? Um,
Intelligent system.
Yeah, well, not just intelligent, but a foolproof solution to the guardrail problem, to the guardrail, uh, destruction or degradation problem. Okay.
Yeah. I would argue that another term might be called sustainability.
Yeah, right. Yeah, sustainability. Exactly. Right.
That's a really good point. Okay, sorry, Steve, to interrupt, but yeah, I mean, sustainability was another set of guardrails that we put on top of controls, right?
Yeah.
As an
Right.
example. Yeah.
Yeah, and I think, when buildings at the, again, design phase are intended at least to produce a certain efficiency if well engineered. And who's calculating that on an ongoing basis? Have I actually maintaining that efficiency? Yes or no? And that efficiency really is tied again to the guardrails. So it's all hand in glove there. But what's kind of, I think, interesting is being able to ultimately look at that efficiency calculation and monitor that as a key KPI, knowing that in order to achieve it, I've got to have a whole slew of individual pieces parts that drive that efficiency, i.e. the guardrails. So as a controls company, it's not going to be easy for us across all the different control components to necessarily build in all those guardrails. I think it's the default condition, if you will, the default control individually of a VAV box, of an air handler, of a chiller. That's one thing, right? But to know exactly how the building would best be suited to run chiller to air handlers to VAV, that's a whole different ball of wax. And I think if you try to put that on each individual controls company, I think we're gonna fail, frankly.
I have a slightly different take. My take is that there really is no governance now because jobs today are basically still being done the way they have been for a long time, which is very minimal specifications for a consulting engineer who's supposed to be providing this guidance, but once again, doesn't know enough about it. So a lot of the decisions today are made by the guy on the upside down bucket still, just before the job is turned in. But what I can say is that the industry is developing governance and building it into the product. So things like ASHRAE Guideline 36, ASHRAE 231, these things that are specifying standard control sequences and manufacturers that are building them into their controls products, that's going to actually be the sort of zeroth and first order effects on governance in the industry, is industry standardization that's still going in. And then we can put AI on top of that eventually. Yeah. The real problem now is
Jim,
no governance.
That's exactly what my company is doing.
Right. I think most of your competitors are as well, Steve. Yeah, I think it's just it's going to be a way to level the playing field, and it will bring a level of standardization to those sequences that would be uniformly different than some guy making it up on the job every time or copying over whatever the best practice was in that branch office or that local building contracting company.
Yeah.
And not to take away from Anno's comments, that stuff is coming. But the zeroth order, the here and now, is guideline 36, 231, things like that.
And
Yeah,
Rick,
I agree. Sorry. Okay.
I was going to bring in Rick just to bring up some of the new working groups, if he can speak, that sort of actually goes directly into this area.
Sure, and you know, we're excited about what ASHRAE is doing in terms of developing those standards and getting them, you know, out on the street to be reviewed and implemented as standards. And then what we want to do with C4SB, the Linux Foundation, is to show those standards in motion, and you know, what are other gaps that can be filled in to be able to apply those, and for manufacturers to be able to, or let's start with the owners, for owners to be able to look at, well, how can that be implemented? How can these standards or these common best practices be implemented? You know, we want to be a place that owners can look for how to specify that full implementation. And it's still, you know, kind of early days on some of this stuff, but we're going to try and move that stuff along fairly quickly, as opposed to the typical way that standards get developed. And there's going to be gaps, right? There's going to be gaps in how different systems move themselves, or, you know, how vendors move themselves to be compliant with that. And so it'll take a little bit of time, but we want owners to know that they can start to expect some more standardized implementations, and then, you know, for the engineers as well, to see that they can specify things in a way that can actually be implemented, can be checked out, and for instance, could actually be checked out by the guy on the bucket that Jim likes to describe, and to have it be more common how control sequences and how control systems are supposed to work. And for that matter, for the AI agent, if that's going to be the one that's checking out to see if things are being done the right way, or if things can be optimized, you know, for the AI agent to be able to sort of check in with the rule book of, yep, this is compliant or not. And but we've got active working groups. We're inviting people to come join and help move it forward as rapidly as possible.
So I could argue, Rick and Jim, exactly that those guidelines and those specifications, those standards are going to be a boon to anyone doing AI, right? Because you're basically defining the rules and the guidelines that if I'm building an AI agent, I'm like, awesome, hand it over. You know,
I was just gonna mention that. I mean, where it's going, I mean, at least where we're going, is the rule book is not generated by humans in the first place.
right.
The rule book is generated by the AI. So that's where our system is going. It's going to automatically analyze any sequence and control and bag of points and figure out the best sequence for that control loop. So that rule book is going to be driven by the AI.
Now, we're gonna have to go at that a little bit careful, is what we're trying to say, is that because of accountability, that you expect to put a stamp on a controls drawing, you can't say right now that AI is going to generate the rules, because of the accountability that the engineer has. Now, once specifying engineers trust the AI explicitly to the extent that they're willing to lose their license over it, then AI can be turned loose to do it. But for a little while, to, you know, walk before we trot, or whatever the saying is.
Yeah, and that's a general theme for any AI, right? They call it the explainability. At the end of the day, can you explain to me what it's doing? And that's always the challenge with AI. And as I'm sure Keith could talk to, you know, AI is, if anyone is using it, and we were just talking about before the start, it's like teaching a teenager, right? And it comes in pretty untrained. You got to train it, just like you train any person, right? Anybody else who gets
This is no different than the 80s when I was working. I'm sure you guys heard about it. Honeywell Care. Okay, control. It's a CAE. It's computer assisted engineering. The fact that you're using a CAE tool, whether it's AI or quantum physics or flux capacitor, it doesn't matter. We've been using CAE tools and developing them, and I've been doing that since 1980s. So yeah, separate the scary AI from the equation. We're already doing computer assisted engineering, and we've been doing that for 40 years.
Totally agree, Keith. And I think that's a really interesting point to bring up. And this goes with Anto's comments as well, which is time constants are very important here. If you
Yes.
look at how long it's going to take this industry to adopt ASHRAE Guideline 36 and standard sequences,
Yep.
that's a decade, right?
Right.
Now, superimpose that on a graph of how fast AI is coming up and what it's going to do. You know, I don't have a divining rod that's going to tell me how those two things go together. But I think, as Anno said, that having those sequences and having that standardization actually gives the AI even more of a leg up, even if it's going to come up with its own algorithms later.
Of course.
Just because, deconvolving every upside down local guy on a bucket across the world is a headache. And if we've got a common starting point, that makes it easier for certainly the humans to follow what the AI is doing.
Yeah, I mean, to meld the comments, you're both Keith's and Jim's comments, I agree 100%, right? Having the guidelines to get started, anybody building an AI agent can get going with that. Is a great starting point. It's a great basis and get everybody going. Then I'm with Keith too, that in the end, it's going to get better, which is a salient point, right? Because we forget this. We forget about the fact that it's great to create a standard. Everyone gets excited. Everyone starts to follow. 5 years from now, how many people are still following it in the building, right? It goes to pot, right? That's why we have continuous commissioning and recommissioning and all those sort of things. And I think that's another area that AI is going to change the equation. It won't forget to not keep it to those things. It'll actually make it better, as Keith says, right?
Anybody ever heard of HVAC Pro at JCI?
Yeah.
I worked
yeah.
on that. People were saying back then in the 80s and 90s that you could never have as much data. You could never answer a bunch of Q&A session from a fuzzy logic control system, a rule-based control system for my sequence, because my sequence is just so complex that you'll never be able to do that. And we proved everybody wrong by doing that. And that's just, it's just AI is nothing more than a force multiplier of technology.
Right.
It's the same thing. This is not a philosophical argument I'm making here. We're doing this stuff right now.
Yeah. And again, back to my original points, the BMS systems were put in place to put guardrails around the control systems in the first place. So
yeah, and they're already there.
And they're already there. So we're not talking about anything new, which is really kind of my argument about when we talk about guardrails. We're not talking about anything new. We've been doing it for decades. The how we're doing it is going to change. Right.
But let me ask a fundamental question here. That if the market is hung up on guardrails, why can't we just say that we have them, even in these AI systems, to ameliorate that concern? Because if we just made the argument just now that we don't care about guardrails, we know they're sort of crap anyways. But if it's a selling and marketing point to say that that's what people want to buy, if they want to buy a guardrail, why is it going to hurt AI to say that we can do that?
It's trust and building trust. Would you want to get into a robo-taxi in Austin, Texas, that have a safety driver there to keep it from driving off the cliff? You would not. I would.
That's true. But if no one was going to try your self-driving taxi without that guy, and I might point out, Keith, that when everybody launched their self-driving cars, they did have a safety driver at the outset.
Sure.
So
And
what
those
I'm
got
saying is
removed.
why not? Yeah, they got removed, but why can't we have a safety driver, which are a few limit levels that don't cost anybody anything
you did
until we
have-
cross that gap?
We've been in business for 6 years, and we just took our guardrails off 3 weeks ago.
Aha. Which means you had the safety
So
system.
we're not against guardrails, but now it's time to take them off.
I'm just saying guardrails as a selling tool, not guardrails.
I see.
At some point, people are going to have to trust that our AI doesn't need guardrails, just like the full self-driving, unsupervised, humanless safety driver.
Well, I'm going to restate Jim's point to you a little bit differently, Keith, and I agree with you on this one, Jim, too, in that, in fact, you actually did it, Keith, right? When you put your stuff in place, you originally had guardrails, and
Yes.
you did that for all the reasons we're talking about, because your clients and customers are
Our
going,
customers wouldn't let us sell it to them
there
without
you
the
go. But
That's
so
the
Jim
point.
is actually
Right.
Jim is making the point of that should be a marketing position, right? There's strength in that statement.
Right.
There's substance in that
I feel
statement. The
that
fact
we
that you
can
did
hit
it that
from
way.
the standpoint of the capability of the AI to be smart enough to not need it. And so, yeah, it's a risk. There's going to be some people that don't want to buy Facil because we took the guardrails off. Nonetheless, they're off and they're going to stay off.
Right.
I like
Oh.
Roger's comment. Engineers are honest enough to tell you it won't work. Marketeers are honest enough to call it a future-ready roadmap.
Yep. Yeah. And that was our argument in our article that we came out with. The guardrails are not protecting the customer, they're protecting the vendors from having to build AI that's smart enough to not need guardrails.
So
Yeah.
I think we're talking about two different levels of things, and I just have to point it out. It's like we're what we're trying to do is we're trying to give guidance to all owners and on all product people. And we have to do that in a way that can be uniformly understood. We're not talking about one product or one company. And so that's a little bit of the difference. So I don't want to be perceived as being disagreeing with what Keith is describing that his product does. But what we're trying to do from across the entire industry is give guidance to how AI can be used for all products and for all companies, and what can be expected when you write a spec and you're trying to get three bids. What can be the base level of expectations, and then different companies can say, here's how we do it, or here's how we get creative, or take the guardrails off or put them on, whatever. That's fine, but there's got to be a base level that the market understands is a level of trust for the industry. And again,
that's a really good point too, Rick, in that, again, I'll use Keith as the example, right? We're going to have a lot of people who are going to go down this path and not be as, honest and straightforward as Keith is, right? Honest. There are going to be people, we've seen it in our industries. People have claimed things that they do in the past that we know don't do, right? And
maybe may have worked for one or two of those,
you
unfortunately.
may have, same here, probably. And so your point is valid, right? Not everyone's going to be a Keith who's going to be. They're going to be people. So how do you help the consumer, the end user, the purchaser navigate that waters, right?
Right, and that should then be very, very helpful for the vendors that excel and that can take you to the advanced level or to the graduate level. And again, but expecting that as we kind of cross into this new AI, dominating every conversation, no matter what you're talking about, AI comes up, right? I mean, over the weekend, how many times did you all have to talk to your friends and relatives about AI for whatever it was? But in this new expectation, people are turning and they're looking for sort of a baseline of definitions of, how is our industry going to adapt to this general concept of AI.
I mean, to me, we're trying to figure out how to cross the chasm, right? Of getting people to the other side where they do trust things. But, maybe you need to provide a crutch of some variety to get them through. And that's my only point here. I'm not saying that's the right point. I'm just saying that, it's not that I don't believe that AI can be made to do these things. I'm not sure I believe that I can, take the curmudgeonly 40-year-old, veteran in the boiler room and get him over that chasm without the crutch. That's my concern.
And our answer, and that's a great point, Jim. It always comes up. Our answer is simply this: if you want guardrails, first of all, they are probably already there. And if you want guardrails around our AI, put the guardrails on your BAS.
Right.
So
Okay.
I was just going to ask the question about, because we were talking about BMSs as basically a form of governance that we've basically created.
Yep.
And we see a future where that can be a lot better with different sort of way of thinking about it. So the question is, what happens to all of the BMS system and vendors that are out there right now?
I coined a term way back when, and I called it the biodegradable BMS system. In that it's not going to evaporate overnight, right? No one's going to walk in the door and go like, hey, I've got this one box that does all the things that, and here it goes, right? I think and we're taking similar approaches internally with AI, right? You're not going to come in and replace everything with AI overnight. Regardless of what your domain is, whether it's in our domain or any domain that you've got. You're going to tackle the big problems. Keith's tackling a big problem, right? Chiller optimization. That's one of our big problems in the space. And you're going to take the problems, and as you get traction and success, you'll go do the next piece. And you get traction and success, you'll go do the next piece, right? There was actually an interesting article by James Dice, in fact, on LinkedIn just recently about things like condition-based maintenance and a few other things. And people are doing the same thing. AI is going to be in that iterative path, get a few things, get a win, get the extra benefit out of that, apply it to the next use case and the next use case. And over time, that's why I called it the biodegradable BMS system. I think over time, the BMS system will biodegrade back to the fundamental controls that it was originally supposed to do.
So Anna, what that makes me think of is, as guidance that we can potentially provide to this effort, and particularly to Rick, is in addition to things like Jim was bringing up, guideline 36 and such, what features, if you will, in the products, in the control products will lend themselves to AI?
That's a really good question.
Right.
Yes.
So some time spent on that question, I think, would be time well spent.
Yeah, that's a really good question, Steve. I agree 100%, right? I mean, how can you optimize those devices now to leverage AI?
Right.
Much better. Yeah,
But you have to be careful as well, because really there's a situation where you can use AI to improve how a VAV is a VAV.
Mm-hmm.
I know you were talking about that earlier, right? Replacing the PID loops with basically AI sort of functionality. So there's a way of using AI in the controller itself to make it a better controller.
Sure.
And there's also the use of AI to be the governing
Optimizer.
Framework for it. So you have to know when you're implementing AI, you must know which one you're doing. Otherwise, you get confused.
I could be extreme in Keith's case, right? At the moment, I mean, he's sitting outside in the cloud and he's using the BMS and the chiller basically as a large set of IOs, right?
Yep.
Some point in time, Keith's software is going to be running in the controller on the chiller on site, right? I almost guarantee it. I'm sure there's some controls companies, chiller guys working on that today, type of deal.
And Rick, is that not basically what's going on at PAE Building?
Oh, interesting.
Ceiling.
The ceiling, you know, the ceiling. Yeah, at the PAE Building, there's an awful lot of siloed systems that are running AI standalone, and so again, a little bit changing the subject here, but we're trying to give visibility and governance to the system of systems, so all the different systems at PAE, which kind of takes it to the next level. Today we've been talking about controls, BAS systems and controls. At the PAE Building, we're kind of going beyond just HVAC to the lighting and the battery and the solar and everything else.
Yeah, so your point is, Rick, there's multiple use cases we have to address in terms of making the products, I'll call it AI friendly.
I like that. I'm going to steal that one, Steve.
Okay. All right, guys, I gotta jump on another call, so I'm going to say goodbye for now.
Okay, Ken, do you want to do a bit of a wrap up on this? You've been listening and
went a lot of directions. I think in my mind the big one is that we inherit a lot of governance as we connect to some of these existing systems. And we have built that in, and I like your biodegradable solution. That's excellent, because that's exactly what I would see, is that you come in and you're going to apply AI thinking. And of course, the next one we have is like the open claw concept, where in fact it will employ other AI agents it'll try and select the best one. So that's kind of a big thought as well, I believe. And we start working with that. And I think we really, as usual, haven't got a clue of what we're doing, but we're having fun and we're moving forward. And I think if we can start to experiment with some of this stuff and just see what kind of goals we can achieve and how comfortable we can make our clients feel and how we can improve the control. I think if we can kind of head in all those directions at the same time. And I believe, that the open claw solution is an interesting thing, because it, as I understand it, would actually deem to bring in another AI agent to try and improve the situation. So that's an interesting, using AI to decide when we should improve AI. So
Yeah,
a lot of
But that is 100% an area where governance is absolutely required,
right.
because all of the stories about OpenClaw doing things that you weren't the owners were not expecting, because it has a lot of power. You've basically enabled it to have a lot of power, so it can be dangerous. So I would imagine that's really where some concept of governance is absolutely necessary.
Actually, in Ben's article that's just on the site, I think came on the weekend, and he starts to talk about that too. So I think there's another thing that is inherent in everything we do, is self-governance. He who creates the solutions, and that's probably all of Keith's success, is that he has actually self-governed exactly what he's going to allow those AI algorithms to do. And that people that are basically writing and posting, it's like Ben on GitHub, they are now starting to see that they too have to take into consideration some of this inside of their big thoughts. So I think we just have to keep kind of growing and trust people. Trust was mentioned, and I think that's an excellent thing. And we just need some more experience, I think.
I do like Jim's takeaway point too, though. We don't leverage what we already have from a marketing messaging perspective. Remember, it just needs. It's not like we're going into the wild west. We're all mature folks who've been doing this for quite a long time and know what to do, right?
Yeah.
I've only blown up one chiller in my whole career, so it's pretty good.
Yep. Yeah, I mean, we actually have a term for that. It's called force resiliency through intelligence.
Oh wow, yeah, okay, like it.
Yeah.
Okay, I think this has been a fascinating conversation. Thank you, Anno, for leading it.
Yeah, thanks. It was good.
We'll get this video up, and I'm sure Ken's AI will regurgitate it and come up with some new insights for next week. So hope you all have a great week.
See you all.
Bye.
Thanks, everybody.
Bye.
Bye-bye.
Bye.
Guys, thanks.